All right, I'm starting to fill it in. I tend to start with the degrees. That is the way my brain works well, is because I'm significantly more comfortable with the degrees. So I tend to start with filling those in. I know my 30, my 60, my 45, and then everything else is just units of that, and it's a rotation. So we've got our 90, 120, 150, 180. That's a 3. I'm going to fix that 3 because it looks like a 5. So there's my degrees. I feel like that is not one of the hard parts. The radians, that's when we kind of got to think in our patterns. I know that this one's 0 and that this one's pi, making this one pi over 2, which makes the halfway between pi over 4. And that this one is then 3 pi over 4. I feel like those 4 all flow together really well. Off of those, we can base our bottom ones because we know that they're always going to be based off of that same rotation, counting up by quarter pies. So this is 5 pi over 4. This one is 6 pi over 4 or 3 pi over 2. And this one is 7 pi over 4. That's part of the reason we're practicing this again. And again, there are lots of different ways to go through the filling in of the circle. And if the way that I'm doing it has you going, wait, huh? Look on YouTube. There's a gazillion different techniques and ways of filling in a unit circle. This is called the unit circle. And if you search the unit circle, you will find about 50 different ways or techniques or tips, tricks, and tools. Things for how to fill it in. So the next one I'm going to do is I know between a half and a quarter, that's where we have our third. So this is going to be our pi over 3. And so this one's going to be 2 pi over 3. This one relates with this one, which makes this one our 4 pi over 3. And 5 pi over 3. And then our last piece of the radians is the sixths. So I've got my pi over 6. This one is 2 pi over 6, also known as 1/3. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8, 9, 10, and 11 pi over 6. So when in doubt, kind of count your way up and work on these patterns. That's a pi. I don't know why it's not drawing a pi. There we go. 11 pi over 6. So again, these are all pieces we have filled in before. And what we're going to do today is we're going to work, for the first half of the day, work on filling in the ordered pairs of this if we're looking at a circle with a radius of 1. So what that means is our kind of 90-degree sets are what we're going to be working with to start with. So if I know that this length is 1, I know that this point is 1, 0. And I know that my 90-degree is 0, 1. Because these are 1 unit out. So this one over here is going to be -1, 0. And our bottom is 0, -1. And what we're going to do when we're looking at finding our ordered pairs is we are actually going to focus in on the first quadrant. We're going to use this first quadrant as kind of our basis for this. Because just like in radians and degrees, everything is kind of based on a rotation. Our ordered pairs are all rotations of the others. So we only really need to figure out these 3. And we've actually already found the values for it. We just found it last Friday when I wasn't here, and we put it in that lovely little table. So every value that's going to be on this chart, you have already written down. And we have already calculated one. Because when we're doing our ordered pairs, what we're doing is we're finding sine and cosine of each of these angles. So if we think about our 45 here, this angle here, if this is our theta, and we're finding the ordered pair of that point, what we have here is going to be, I'm trying to find a place to write it on this thing, and I don't really like writing it like that. Okay, so I'm going to get rid of those dots. Our ordered pairs are going to be our cosine of theta, comma, sine of theta. Every single time. They're always cosine sine. So what I'm going to do is we're going to think about cosine of 45 degrees and sine of 45 degrees. And if you go grab that table from last Friday that you hopefully have in your notes, should look like that. It was the day that I was gone. Hopefully the sub gave you that table. The sine of 45 degrees, we found that already. It's not based on our radius at all. The sine of 45 degrees was the square root of 2 over 2. The cosine of 45 degrees is the square root of 2 over 2. We found it on the table. So it's based off of the, if you remember the equilateral triangle and the 30, 60, 90 triangle, these values are all based off of those. Because our equilateral triangle, remember that was our 45 degrees on either side, 30 degrees, 60 degrees. We have the values for it. We're just putting them together here. So it's the same thing as the 30, 60, 90 and the 45, 45 isosceles. We just have to remember that we put them as cosine and sine. So for the 30 degrees, the cosine of theta, I'm sorry, I'm going to keep this out here just because otherwise I'm going to have to zoom in a gazillion times. The cosine of 30 degrees, that's our square root of 3 over 2. And the sine is 1/2. cosine, comma, sine. For our 60 degree, they're flip-flopped. It's the same as the 30, but they're flip-flopped. So it's 1/2 square root of 3 over 2. From those 3 points, we can get every other ordered pair in this thing. Because if we think about a coordinate plane, coordinate 1, x is positive, y is positive, right? Which this means cosine is going to be positive and sine is going to be positive. Quadrant 2, x is negative, y is positive. So our cosine is going to be negative, but our sine is still positive. So if we come into our ordered pairs, and this is when my colors here actually start to make sense, our thirds, it's the same values over here, except my x is negative. It's a reflection over here. So the only thing that's different is that my x value is negative. So for my little green one on the left here, we have our negative 1/2 square root of 3 over 2. We can start to see why the tiny graphs are a little bit harder to fill in, because there's a lot of things in here. For our purple one, again, the only thing that's different is that my x is negative. So we're going to have the negative square root of 2 over 2, square root of 2 over 2. For my blue one, same thing, negative square root of 3 over 2, positive 1/2. Quadrant 3 is very similar. Sensing a theme here? Another rotation. Quadrant 3, this time we have my x being negative and my y being negative. Meaning both my sine and my cosine are negative, though I have that in a different order. Cosine is going to be negative and my sine is going to be negative. Which means if we think about it, our tangent would be positive. So it's, again, the same ordered pairs, just everything is negative. So we have our negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. Ooh, that one's impossible to read. Hang on, I'm going to rewrite that green one down here. Negative 1/2, negative square root of 3 over 2. And then we only have one more quadrant left. We have quadrant 4, where my x's are positive, but my y's are negative, which means my cosine is positive, but my sine is negative. So filling in our unit circle, we have our, whoop, wrong color, 1/2 negative square root of 3 over 2. Square root of 2 over 2 minus square root of 2 over 2. And our very last piece here, square root of 3 over 2 minus 1/2. So if we focus on memorizing these three ordered pairs, which is why I kind of broke it in chunks. We could do the degrees and radians in one chunk mentally, and then our ordered pairs in a separate chunk. I was trying to hopefully make it a little easier. If we memorize these three, you guys know how to work a coordinate plane. And if we remember that they're reflections, it helps with that. Again, if the way that we did this does not work for your brain, check YouTube. There's about 50 different techniques, methods, tools, tricks, tips, cheats, whatever, for how to remember how to fill in the unit circle. There are a gazillion different ways to do it. And I do not care what order things go down on your paper. Just that they go down on the paper. Okay? So I do not care if you do it my way, if you do it someone else's way, if you come up with your own way. I don't care. Whatever works for your brain to get this put onto the paper in about 3 minutes. Okay? That's the goal. And we're going to have a lot of opportunities to do it. This is going to be like, it's like the one quiz we're going to retake. And we have it planned already to retake it 3 times during class. Okay? So like, we're going to keep doing it till we get it. It's one of those things that's going to come up repeatedly, repeatedly, repeatedly. Okay. Questions on this part? Because we're going to take this little piece down here, where I kind of mentioned that our cosines are positive and our sines are positive. We're going to play with this for a little bit, just to get us used to thinking about cosine being our x and sine being our y. So we're going to play with that for a smidge, to kind of identify what quadrant an angle will be in if we have some information. Okay? And I have made myself a note to move that back to the day we do that table, because I hate the fact that it's almost a week away from when we filled in that table. I don't like that. Yeah. All right. Nope. Hang on. We're going to do this first. There we go. All right, so what we're going to do is we are going to figure out what quadrant. We're not finding out an angle. We're not finding anything like that. We are figuring out what quadrant it's going to be in if I know about this positivity, negativity thing on these particular sides. So we're going to think about that little coordinate plan that I put on the bottom. I'm going to put over here. So 1, 2, 3, 4. And so this one had okay, so I've got it over here again so we can see it here too. And what we're going to do is we're going to try and figure out what quadrant it would be in if it had these values. So if sine is greater than 0, is that positive or negative? Positive. And cosine is greater than 0, positive or negative? Positive. So if sine is positive and cosine is positive, what quadrant is this in? 1. Okay. Sometimes they like to throw us in our head over here. So then let's look at the next one. Cosecant is less than 0. How do we write cosecant in terms of sine and cosine? I did erase it. Cosecant is what? 1 over sine. So if cosecant is less than 0, is sine positive or negative? Negative. Because it doesn't matter if this is 12 or a half. If it's negative, the whole sucker's negative. So if cosecant is less than 0, sine is negative. And if cotangent is negative, cotangent being what? How do I write it in terms of sine and cosine? Cosine over sine. So if I know that sine is negative, is cosine going to be positive or negative? Negative. Is it going to be negative? If I have a negative over a negative, it would be positive. So I know cosine has to be positive for all of cotangent to be negative. Right? See that? Okay. So if sine is negative and cosine is positive, what quadrant is it in?
No. 2. No.
I have heard 3 out of 4 options so far. Take a breath. Lock it in. 4. Just because I pause doesn't mean you're wrong. It means I want to make sure everybody else sees it too. Lock it in. It's 4. Have confidence in yourself. All right, then we got cosine greater than 0 and tangent less than 0. So is cosine positive or negative? Positive. So I know cosine's positive. Awesome sauce. Tangent being negative, when I know cosine's positive, means what do I know here? Sine is negative. So if sine is negative and cosine is positive, what quadrant are we in? 4. Okay, so there's not a ton like that, but there's definitely some like that, so we wanted to make sure we got through that. Okay, I do have that scheduled to shift back to overbe when we did those triangles, because the fact that we waited a week is going to drive me nuts. I don't know why the book had it in this order, but the book had it in this order, and it's annoying. Okay. So what we're going to do next is we are going to look at, there's some problems like this where I give you an ordered pair, and you are asked to figure out what the degree is, or what the trig functions are. So theta is going to be an angle. Standard position just means it's on the x-axis. And we're giving you a point, x comma y. So this is a point that we give you that's on the terminal side of your angle. So what we're giving you is on our coordinate plane, I'm giving you a point. It doesn't matter where it is, but I'm gonna say here. I'm giving you x, y. And what I'm asking you to do is to find all 6 trig functions based off of this point. It's always going to be centered around the origin. And the first thing we're gonna need to do is we need to figure out this distance. We're gonna figure out the distance between the origin and our point. That's what it's talking about here. I just feel like there's too many equal signs and it looks chaotic. So what we're saying is the distance between the origin and our point is the radius of some circle. I could make a circle with that. Boop, boop. I draw it, but I'm trash at drawing circles by hand. That is not my skill set. There are some people that can do like that perfect circle with the elbow trick. That's not me. That is not me. Is that? Okay. So what this means is we're going to use this ordered pair and the distance between the ordered pair and the origin to fill in all 6 trig functions. And it's actually going to use whatever this distance is. This distance we're calling r. We're giving it a name. We're calling it the radius of that whatever circle. And then we're going to use the points or the numbers from the ordered pair, x and y, to give us all of our trig functions. Because this is a triangle here. If we think about this side being x, this side being y, because it went over this many pieces, up that many pieces, and that is going to be our radius. That's where that distance formula came from. It's the Pythagorean theorem. If we think about this being a triangle and this is the angle that we're thinking about here, we can get all of our trig functions based off of all the things we know. Sine is our opposite over hypotenuse, remember? So our sine of theta is going to be y over r. The cosine of theta, adjacent over hypotenuse, x over r. And tangent of theta, opposite over adjacent, y over x. So it's using the fact that we can make a right triangle on a coordinate point easy peasy, using the x and the y of our coordinate point, okay? So the other trig functions are, again, they're just the reciprocals. So cosecant is r over y. Secant is r over x. And cotangent is x over y. They're always the reciprocal with each other. And this here is the last concept in 6.2. Okay, so this is finally the last piece of 6.2. We've been in 6.2 since Thursday of last week. It took us a whole flipping week to get through 6.2. There are too many things in this section. I don't know who designed this textbook, but they are a crazy person. Just saying. Too many dang things. Okay, so we're going to practice this a few times. I'm going to give you a point. We are going to find all 6 trig values. Ready to go? I don't see anybody writing still, so we should be good. Okay, so I'm giving you the point negative 15, 8. So if it helps you, give yourself a little sketch. Doesn't have to be pretty. Negative 15, 8. So it's going to look something like this. It's not a pretty sketch, but it gives us an idea on how it is. And so we know the length of this side, I'm gonna write clean here, is -15. And we know the length of this side is 8 because that is the address of this point. So we need to figure out the length of our hypotenuse so we can find all of our trig functions. That's our R. That's the guy that we need to be able to figure in everything. So what we need is the distance from the origin to our point P. And what that is that's the square root of my x, -15 squared, plus my y, 8 squared. What is -15 squared? It was whispered, but I heard it. What is 8 squared? 64. What's 225 plus 64? 289. What's the square root of 289? Close? Less close. 17. So what that means is that R is 17. The distance here is 17. I always find it handy to draw the picture, but I am a visual person. If it helps you to draw the picture, I highly recommend it. If it doesn't help you, there's never a penalty for not drawing a picture. If you can do it in the head, I'm impressed by your graphical interface in your head. Mine won't hold that many pieces of information. So what we're going to do is we are going to find all 6 trig functions of this angle. So we're going to do sine of our angle, theta. That's this guy. We call it theta. What is our sine going to be? Remember our SOHCAHTOA. 8/17. Sine is our opposite over hypotenuse. This is why I think a picture helps. Helps with that. Fill in the blank. Pretty easy. Cosine of theta. -15/17. I'll leave a gap just because my fractions get close together. Tangent of theta. 8/-15. Okay. To figure out our other 6, you can think them or you can remember that these are all inverse relations. Cosecant is the inverse of sine. 17/8. Secant. 17/-15 or -17/15. Cotangent. -15/8. Okay. So your first step on these when you're given a point is to find your R. You got to find your R. You got to figure out what your hypotenuse is. Sometimes they're pretty, sometimes they're not. This one is pretty. It's a nice whole number. Sometimes it's a square root. That's fine. Just rationalize. When you get down here, you'll probably have to rationalize some of them because we'll wind up with it in a denominator. But you can do that. But sometimes they're not going to give us quite all the information, and I want to practice one where they don't give us everything right off the bat, like a point. They're going to give us a value. And they expect us to use all this stuff to figure it out. So I think we might only have time for one. So I'm gonna just do the left one that's on this page. Yeah. We'll do the right one if we have time. So I'll leave it up there, but we're gonna use the information we just have to figure out the other values for the trig functions. So if I know we have a tangent of -3/4, so my tangent's negative, and my sine is greater than 0, what quadrant is it going to be in? If sine is positive but tangent is negative? 2. Because it means my cosine's negative, but my sine's positive. So this is going to be in quadrant 2. So the reason I care about that is it helps me draw a little picture real quick. I know it's going to be in quadrant 2, so it's going to be somewhere like this. And what tangent tells me the length of my sides. So I know that my y is 3 and my x is 4. Ooh, that's trash. Try that again. There we go. So what's my hypotenuse going to be? Yeah, 3, 4, 5 is a standard triangle. Like a 3, 4, 5 triangle, that's a thing. Or you can always go, you know, and Pythagorean it. 3 squared plus 4 squared equals c squared. Figure out your r that way. From here, we can fill in those trig functions. Sine of theta is going to be 3/5. One thing we need to be careful with when we're filling these in, all these values are showing positive right here. Cosine needs to be negative because this really moved 4 left. Okay, so be careful on these ones to make sure we pay attention to the signs of all the things, because we need to make sure we wind up with our cosine of theta being -4/5. My cosine needs to be negative for this to land in quadrant 2. So that's why they gave us this data, was to help us figure out which of these pieces need to be negative. Our tangent, they've already told us at the beginning, was -3/4. They gave us that one. And we're definitely not going to have time for the other one, so I'm going to use this space over here. So our cosecant is going to be what? Cosecant? 5/3. Secant? 5/-4 or -5/4. Cotangent? -4/3. Okay? That is finally the end of 6-2. Holy cow, we've been in this section for a week. Tomorrow, we're going to do review for the quiz, because holy cow, is this a lot of stuff we've been through in the last week and a half. We're going to do review. Okay, and I'll have a whole review page for you to practice all the types of questions that we've got. All right? Except I think there should be homework C. Make sure you check for homework C too. Yes, dear.
You posted the assignments of the homework on Canvas.
Yes.
You want me to send an email?
No, you still turn them in the bin. I'm just putting them up on Canvas so that we can play the what if game when it comes to like what do we need to get on this test? What happens if we what do we need to get on the final? I've been noticing with college courses especially, they're starting to exclusively use Canvas for grade tracking, and so I'm kind of trying to get us in the habit of checking that, and then we can play those kind of, what happens if I don't turn these homeworks? If I go and pick up all these homeworks, what's going to happen in my game? We can play the what if games in Canvas, they have that built in.
Thank you.
Uh-huh.